गुड आफ्टरनून ऑल। ओह माय गॉड, कौन है ये बंदा? प्रशांत
मिश्रा।
प्रशांत मिश्रा कौन है ये? कोई पॉलिटिशियन का नाम है?
स्टूडेंट है।
ऑब्वियसली स्टूडेंट्स अभी यहाँ पर स्टूडेंट नहीं होता तो यहाँ क्यों होता?
अच्छा, लड़का है।
अब लड़का हो लड़की हो जो भी हो, पर यहाँ आप जिस तरह से खुश हो रहे हो मैं वही पूछ रहा हूँ। प्रशांत मिश्रा जैसे आपने बोला, मुझे लगा मैं भी किसी पॉलिटिशियन का नेम है फेमस, मुझे ना पता नहीं। Anyways guys, we were talking about the autocatalytic reaction. Good afternoon guys. A very good afternoon to all of you. Now let's talk about the autocatalytic reaction. And guys, please check the schedule from tomorrow. Some new subjects will be start in your batch. So let's talk about the autocatalytic reaction. So what is autocatalytic reaction? That is as the name suggests, any reaction in which autocatalytic means some of the component of the reaction mixture is itself acting like a catalyst. Okay, we are not sending any catalyst, but some of the component present in the reaction mixture itself is acting like a catalyst. Okay, means when the reaction start, and if you see the reaction versus time graph, so the curve will be something like this, and suddenly it increases. Suddenly the curve increases, the rate of the reaction increases rapidly. Okay, I know that it's not you, there are two Prashants in our classes. Anyways, autocatalytic rate of reaction suddenly increases. Okay, and I hope all of you can understand that during the reaction, if rate of reaction rapidly increases, suddenly increases, but after some time, so it's obvious one of the component which is acting like a catalyst, that is definitely a product, because if reactant acts like a catalyst, so rate of reaction should be high from the starting itself, not in the middle of the reaction. It should increase from the starting only. Okay, so some of the product is acting like a catalyst, that's why in the middle of the reaction rate of reaction increases rapidly like this. So if I have a reaction, suppose A gives R, so R is acting like a catalyst, so we can write it as A plus R gives R plus R. As catalyst also we know the catalyst, we know the characteristic of the catalyst. What are the characteristics? First, it participates in the reaction. A catalyst participates in the reaction. So product R, which is acting like a catalyst, it will participate in the reaction. Okay, and A is converting into R, so this A will convert into R. And we know that one more characteristic of the catalyst, that is a catalyst participate in the reaction, but after the reaction completion we get the same amount of catalyst back in the mixture after the reaction completion. Okay, if there is a catalyst which is participating in the reaction, so after the reaction completion we will get back the same amount of catalyst, so R will be back after the reaction completion. So that's how we represent the autocatalytic reaction. And what will be the rate of reaction? So rate of reaction, you can define it as, you can write for this reaction as K Ca power alpha Cr power beta, where R is the product. Don't forget that R is the product which is acting like a catalyst. Okay, but since it is on the left hand side of the reaction, that's why we will include this. And here if you want to write this for CVRS system, so I hope all of you know that Ca will be equal to Ca naught 1 minus Xa, and Cr will be equal to Cr naught plus R by A times of Ca naught into Xa. That's how you can write the concentration in terms of XA. Okay, so how can we solve this? Let's try to understand. Suppose we have a reaction, A plus R gives R plus R. So rate of reaction will be, let's say that is first order reaction. Apparent order is 1 for both of the reactants. So overall order is 2. This is second order reaction and first order with respect to reactants. So for constant volume reaction system, we know that minus Ra can be defined as minus dCA by dt, that is equal to kCa Cr. So here I want to solve this. So obviously you have to change Cr in terms of Ca, or otherwise you can change Ca and Cr both in terms of some third variable like Xa. Okay, if you remember, we discussed the kinetic equation for second order reaction having 2 or more reactants, like A plus B gives something, where we discussed 2 cases, if feed is in stoichiometric proportion, if feed is not in stoichiometric proportion. So there we use the approach where we change Ca and Cb both in terms of Xa to find out the kinetic equation. Okay, I hope you remember that. Here we will not use the same approach because I hope all of you know how to use that thing. Here we will discuss one more approach, okay, that is in terms of concentration. How can we change Cr in terms of Ca and solve this in terms of concentration only? Okay, so as this is constant volume reaction system, so we know that for constant volume reaction system, total moles at any point will be same as initial total moles. So here at any time t, total moles will be Na plus Nr. Initially it will be Na naught plus Nr naught, let's say Nt naught. Okay, so if you divide this by volume, we know that V is equal to V naught for CVRS. So Ca plus Cr, that will be equal to Ca naught plus Cr naught, or you can say Ct naught. Okay, so what will be Cr? Cr will be Ct naught minus Ca. So just put this value of Cr here in terms of Ca, and I hope then you will be able to solve this. So it will become minus dCA by dt is equal to kCa times of Ct naught minus Ca. And further you can solve this kinetic equation very easily. So use the variable separable method. It will be minus dCA over Ca times of Ct naught minus Ca, that is equal to k dt. And I hope you know the limits. At reaction time t equal to 0, concentration of A in the reaction mixture will be Ca naught. At any time t it will be Ca. Okay, so on right hand side you will get Kt, on left hand side you can use partial fraction method to solve this. So I hope all of you know how to use the partial fraction method. So when you use the partial fraction method for this, it will be like 1 over Ct naught 1 over Ca plus 1 over Ct naught minus Ca. This will be the partial fraction for this. This is Ct naught. So integration from Ca naught to Ca of 1 over Ct naught times of 1 over Ca plus 1 over Ct naught minus Ca dCa. It will be 1 over Ct naught ln of this will be the integration of solution for this integration. So final kinetic equation will be and it is easy to memorize that this is the partial fraction. So what is the integration of 1 by Ca? ln Ca naught over Ca. So ln Ca naught over Ca. This term is there. When you integrate this, 1 minus sign will come. So that's why the limits of this function part will be reversed. So it will become Ct naught minus Ca over Ct naught minus Ca naught. Okay. So that's how you can memorize this equation as well if you wish. Otherwise you can solve it, and hardly it will take 1 minute of yours to drive this expression. This R is not depends on you. This R is present initially or not, but this is the way to write down the autocatalytic reaction. As I told you, this is the reaction A gives R. If R is present initially or not doesn't matter, forget about that. During the reaction what is happening, just focus on that thing. A gives R. R is a product which is acting like a catalyst, and we know the characteristic of the catalyst. What are the characteristics? First, catalyst participate in the reaction, and after the reaction completion we get back the same amount of catalyst. Okay, so A gives R, and R we are getting back even after the reaction completion. So that's how we represent the autocatalytic reaction. If it is present initially or not, that depends on the process, that depends on you. Okay, the best example of autocatalytic reaction is the formation of curd from milk. If you have 1 liter milk for example, and you want that 1 liter milk to convert into curd, then you have to keep it in some reaction conditions, so that milk will be able to convert into the curd, but it will be a slow process. Okay, but since we want the formation of curd to happen in a small span of time, as soon as possible, so what we can do with that 1 liter of milk, we can add a small amount of curd in that milk. Okay, from the starting. So that curd which we are adding in the milk, in the reactant, it will act as a catalyst, and the formation of milk into curd will increase. The rate of formation of milk into the curd, rate of conversion of milk into the curd will increase rapidly, and we will get the curd in a small span of time. Okay, I hope all of you can relate with this example, as it is one very common example which our parents, grandparents, 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 grand to the power infinity parents, all of these people are doing from the starting of the, not humanity, but from the, I don't know, from the starting of the humanity, yes, not the earth, from the humanity. Thanks, sir. Thank you, Sajid, for asking this doubt. So I hope this is clear, guys. Is it clear to all of you? How can you find out the kinetic equation? Okay, this is the method to find out the kinetic equation in terms of concentration only. Similarly, in that method, in that example, the kinetic equation for second order reaction having 2 or more reactants. Okay, there as well you can use the same approach to find out the kinetic equation in terms of concentration. Okay. And the approach we use there in terms of conversion, you can use the same approach here to find out the kinetic equation in terms of conversion. So it's quite easy to understand. Now let's talk about the autocatalytic reaction. There are some points, some characteristics of the autocatalytic reaction which you should know. Okay. And to understand those characteristics, let's take one simple example. What are the characteristics? These are, remember, for autocatalytic reaction, rate of reaction will be maximum when Ca is equal to Cr, or you can say Xa is equal to 0.5. Okay, you can understand this with a very simple example. Okay, suppose I have a reaction A plus R gives R plus R. Let's say initially I am sending 11 moles of A and 1 mole of R. So total moles are 12 initially. Initially I was having 12 moles of A and 0 moles of R. But after a very slow reaction, after so much time, after having a slow formation of R, 1 mole of A was able to convert into R. So at time t1 we have 11 moles of A, 1 mole of R. So total is 12. Okay, now just see the reaction mechanism. What is happening? Step by step. Okay, so here we have 11 moles of A, 1 mole of R. So see, this 1 mole of R will react with 1 mole of A to give 1 mole of R each. Total will be 11 minus 1, 10 moles of A will be remaining. So 10 plus 1 plus 1 equal to 12. Okay, now we have 10 moles of A, 2 moles of R. So what will happen? Now 2 moles of R will react with 2 moles of A. So 8 moles of A will be remaining and 2 moles of R will be formed. So 8 plus 2 plus 2 total is 12 again. Now we have 8 moles of A and 2 plus 2 4 moles of R. So what will happen? Now 4 moles of R will react with 4 moles of A. So 4 moles of A will be remaining and 4 moles of R each will be formed. So total will be 4, 4, 4, 12. So what we have? We have 4 moles of A, 8 moles of R. Now 4 moles of A will react with 4 moles of R. So 4 moles of R will be remaining and 4 moles of R each will be formed and total will be 12. So you can see that's how the reaction is taking place. Okay, and in this reaction mechanism you can notice one thing. Initially when we have 11 moles of A, 1 moles of R, or you can say Ca greater than Cr, simply NaCa, Na0, Ca0, NrCr, Nr0, Cr0 are same here. Okay, so Ca is greater than Cr, so only 1 mole of R is reacting, 2 moles of R is reacting, 4 moles of R is reacting. When we have Ca less than Cr, when we have Ca less than Cr, so 4 moles of A, 8 moles of R, so only 4 moles are getting reacted. Okay, so now just try to understand. During this process, there will be a point when Ca is equal to Cr, means when we were having 6 moles of A and 6 moles of R. At that time, what will happen? All 6 moles of A will react with all 6 moles of R to give this. Means total all of the A, all of the R will get react. Okay, so you can see that the maximum amount of A, the maximum amount of R is reacting when the concentration is same, and when maximum moles will get react, so rate of reaction will be maximum, as rate of reaction is proportional to dN by dt. dNA by dt means moles of A reacted upon per unit time. Okay, so I think this is clear to all of you, and here you can see Ca will be Cr when initially Ca0 was 12, now Ca is 6. So what is the conversion? 50%. Okay, condition is no product form is introduced initially. Okay, so in autocatalytic reaction, when no product is introduced initially, so when the moment when Xa is equal to 0.5, rate of reaction will be maximum, or otherwise this point is valid for all the conditions. Either you introduce the product or you don't introduce the product, doesn't matter, but if Ca is equal to Cr, rate of reaction will be maximum for sure. And since this is second order reaction, so for second order reaction we know that rate of reaction, the curve of rate of reaction will be parabolic. Okay, so if you draw the curve, it will be like, if you draw the curve between 1 over Ra versus Xa, it will be like 1 over RA versus XA. It will be like this, and this value will be maximum when XA is equal to 0.5. Okay guys, see, when Na is greater than Nr, only 1, 2 or 4 moles are getting reacted. When Na is less than Nr, still 4 moles are getting reacted. So just try to imagine, there will be definitely a point where when 6 moles of A and 6 moles of R will be available. At that time you can see 6 mole A will react with 6 mole R. So total all the moles are getting reacted. So the rate of reaction will be maximum in this case, as R is proportional to dNi over dt. Since most of the molecules are reacting, maximum number of molecules are reacting when Ca is equal to Cr. So rate of reaction will be maximum when Ca is equal to Cr. And when we will achieve this point? We will achieve this point when Xa is 0.5. But for this condition, for second point, the condition is Nr naught should be 0. For first point, this condition is not required. Either you introduce the product or you don't introduce the product, doesn't matter. But in this case, for X equal to 0.5, this condition has to be there. Okay. And what will be the best suitable reactor arrangement? That we can easily find out. So just convert this curve into a performance curve. And what will be the performance curve? When we do the reciprocal of on y-axis, means when we draw the curve between 1 over RA versus XA. So it will be like this, where this value is 0.5. Okay. And what will be the best suitable reactor arrangement? That you can understand, as we have 2 segments, so we require 2 reactors in series. And what will be those 2 reactors? This is the performance curve. Area of performance curve represents the volume of reactor. Volume of reactor is an input, so it should be minimum. So we will prefer those reactors which will require the minimum area. So like first case, area governed by PFR will be this area. And area governed by the MFR will be this. So you can see, for first segment, MFR requires the less area. So we will prefer, if Xa is less than 0.5, we will prefer MFR. And if Xa is greater than 0.5, then, like for this case, area governed by MFR will be this area. And area governed by MFR will be area under the curve, which is this only. Okay, so for Xa greater than 0.5, we will use MFR. Okay, so what will be the best reactor arrangement? Simple. If you want to achieve 40, 50, 45, 36, 20, any percent of conversion, okay, the overall conversion is less than 0.5, then simply use MFR only. Okay, but if overall conversion required is more than 50%, for example, we required 70% conversion or we required 80% conversion, then what we will do? So we will use MFR to achieve 50% conversion, and after that 50% conversion we will use PFR to achieve the remaining of the conversion, to increase the overall conversion from 50% to 80% or 75%, whatever is required. Okay, so that's how we will use MFR followed by PFR. Okay guys, so this is something about the autocatalytic reaction, and now I can say officially that your homogeneous reaction system part has been completed from my side. Now you should be able to get 8 to 10 marks in your CRE, means all the 8 to 10 marks in your CRE in GATE 2021. Okay, because the weightage of homogeneous reaction system is 8 to 10 marks, and the weightage of heterogeneous part, which we will discuss now, the weightage of that part is only 1 to 2 marks. You will get only one question from that, either for 1 mark or 2 marks. Okay, maybe sometime you may get 2 questions for 3 marks as well, but normalized, if I talk about normalized marks, in terms of normalized marks, then you will get only 1 or 2 questions of maximum 2 marks only from heterogeneous reaction system. So we will discuss that. The condition NR not equal to 0 is, just try to understand here. Suppose I have Na not equal to 12 and Nr not equal to 1. So total moles are 13. So Ca equal to Cr, this condition will be achieved when we have 6.5 moles of A and R. And when we have 6.5 moles of A, 6.5 moles of R. At that case, you can see Xa is not 0.5. Okay. So rate of reaction, we cannot say rate of reaction will be maximum at Xa equal to 0.5. So I hope it is clear now. So when Nr naught is 0, Nr naught is 0. In that case, Ca equal to Cr means 6 moles of A, 6 moles of R. Now you can see 6 moles of A and 6 moles of R. This condition is achievable. So this condition is achievable. So what is the Xa here? Xa is 0.5. Okay. So that is the thing. For first point, Ca equal to Cr, that you can achieve any time. For that, initial concentration of R may or may not be 0, doesn't matter. Okay, like simple, at your home, if you want 1 kg of milk, now I am talking about the amount of milk in terms of mass. Okay, you want 1 kg of milk to convert into 1 kg curd. Okay, SF means within seconds or within no time. Then what you need to do? Just add 1 kg curd with 1 kg milk. Then when 1 kg milk, 1 kg curd, the amount is same. Rate of reaction will be maximum. You will get the 2 kg curd in less span of time. Okay. But if you add only 100 gram or 10 gram of curd with 1 kg milk, then the entire 1 kg milk will be able to convert into curd after some time. It will take some time for that curd formation. Okay. So I hope it is clear now. When it is applicable. Applicable means, I just give you one example. I didn't get your point. When it is applicable means what? It is applicable every time. Autocatalytic reaction. This is the kinetics. So this kinetics is valid for all the autocatalytic reactions. So, but I didn't get your point. What you want to know? When it is applicable means what? Can you please explain what you want to know? Just try to understand. I am telling, forget about this point for now. This is clear to you, I hope. So for this case, Cr naught is 0 or Cr naught is non-zero, doesn't matter. Whenever this thing is there, rate of reaction will be maximum. Okay. Like initially, if you fed 12 moles of R with 12 moles of A, so we don't need to discuss all these things. We can simply see 1 mole A react with 1 mole R, 12 mole A will react with 12 mole R. So in one step only, all the moles will be reacted. And when all 12 moles are getting reacted, so rate of reaction will be maximum. Now if we have 12 moles of A and 12 moles of and 1 mole of R initially, total is 13. So Ca equal to Cr, when we will be able to achieve this condition? When Na is 6.5, Nr is 6.5. So when both are equal, total is 13, as total has to be 13 here, since this is CVRS system. Okay, so in this case, rate of reaction will be maximum. But what will be Xa? You can see Na naught is 12, Na is 6.5. So Xa is not 0.5. Okay, Xa will be different. It will be some different value. But if Nr naught is 0, then when this condition will be achieved? When Na and Nr equal, means when the value of Na and Nr is 6. Both are 6. And when both the values are 6, then what is the Xa? Xa is So nr naught should be 0 for this point. Okay, for this point. Only then we can say at x equal to 0.5 rate of reaction will be maximum. So I hope guys now it is clear to all of you. So let's move